values. Okay. Find your vertical stretch. If the amplitude is greater than 1, vertical stretch. If it's a fraction between 0 and 1, then it's a vertical shrink. Okay. If you have something out here, if you have a +2, -1, this is a vertical shift. And then if you have a reflection, we don't do too many. We don't have too many in there, right? Just a horizontal stretch or shrink, vertical stretch or shrink, and a vertical shift, and a reflection. So not too many. All right, so this guy, if it's helpful, pull this fraction out. This is your frequency. Okay, it's less than 1. So what it's going to do is stretch your curve out. Think of when you do 1/2. When you do 1/2, isn't it half the curve in 2 pi? Isn't it stretching it out? So you've got a vertical stretch, and you can say by a factor of, just take its reciprocal, 5/2. Find your period. Again, give me your period. Period is 2 pi over b. Keep these in radians. And again, amplitude. The amplitude gave you a vertical stretch. The domain on the cosine and sine, all real numbers. That's not going to have any effect on anything. Only for cosine and sine. We're good? Stop me if you have any questions. Okay, this guy, we have an amplitude change, we have a reflection, and we have a frequency change. So the reflection is your negative. This guy, because it's less between 0 and 1, you have a vertical shrink. If it helps you, do your -1 to +1, and multiply everything by 1/4. So -1/4 to +1/4. An easy way to get your range. For your period, 2 pi over b, so your period is larger, you have a horizontal stretch. If your period becomes more than 2 pi, and 2 pi, if you multiply 2 by 3.14, that's 6 something, 6.28. So 8 is bigger than that. So you're stretching your period. So there's your stretch of your graph. Good? I'm taking that as good. This guy, you have a phase shift. Make sure you refer to this as a phase shift. It is a horizontal shift, but because it deals with an angle, we call it a phase shift. So again, your amplitude, now even though this amplitude is in a fraction, it is greater than 1. It's 2.5, so you're stretching this. So this is a vertical stretch. And we have a phase shift, pi units, c over b, pi units to the right. It goes the opposite direction. If it's a negative, it goes to the right. A positive, it goes to the left. If I ask you for a complete cycle, this gives you a complete cycle. And this is what I'm looking for. Normally your complete cycle goes from 0 to 2 pi. It goes all the way around your unit circle. But because you started at pi, this is where it's going to start. Where is it going to end? Now, this one's not so bad because you didn't change the frequency on this. The frequency is still 1. It's still going to need 2 pi to complete that, right? So if you started at pi and you added 2 pi, this would put you to 3 pi. So if you kind of think that one out logically, it makes sense. If you want to stick to the equation, always set this equal to 0 and then set it equal to 2 pi because that's where your normal cycle goes from. Yes, these curves are continuous, but we've got to have a starting place where they're going to stop and not an ending place, but a place to really start it. So one complete cycle will go from pi to 3 pi. Are you guys good with this part? Okay? Because you're going to need to know that too, where your full cycle is. Okay, so this I asked you to graph. Find the intercepts. When you're looking for your intercepts, that's what you use for your sine curve. That's your 0, 1, 0, negative 1, 0. This is your intercepts, your zeros, your maximums, your minimums. If they change because of an amplitude, just multiply them. If they change because of a shift, add or subtract it. I didn't have this?
No, it's 18.
It's not in the table.
18.
Oh, I'm sorry. So you have this one now?
Yeah.
Okay. Sorry about that. Okay, so you've got an amplitude change of 3, no other shift. So now multiply this whole guy by 3. You've got a frequency of 2, which means you need to fit 2 and 2 pi. So the period is going to be pi. Take pi, and now section this right here into 4 quadrants. Yes.
Well, when you write your intercepts, can you write it like n pi over 2? Or, you know what I'm saying? Like when we do the
That's only when we do like the domain restriction with the asymptote.
Okay.
So, because you're basically saying, well, yeah, it won't work for this one though. You're going to say every pi over 2? Are you going to say n pi over 2 every integer?
Yeah.
Did you make this say pi over 2 every integer?
Yeah, I had n pi over 2.
Every integer? I'd rather you list it out this way. I see what you're saying because it's continuous. But we only have to do that for the asymptotes and the domain restriction.
Okay.
But it wouldn't be wrong. I can absolutely see what you're saying.
Okay.
And don't forget, even though this is an endless curve, we're just graphing for this little section. Whether I go from negative 2 pi to positive 2 pi or 0 to 2 pi. Okay. What's key here is this. Always take your period and divide it by 4. This gives you your quadrants. This is what's giving you your mins, your max, and your zeros. Okay, and remember radians. Everything's in radians. Is it getting a little easier in radians? No. But when you do this, John, the easiest way to do this is don't like think in terms of angles when you come down here. Just the first one. When I take this and I say I need to complete it in pi, right? And I need to section this in 4 pieces. Half a pi is pi over 2, 90, right? And half of 90 is what? Pi over 4. So all your tick marks count from pi over 4. Don't translate it in your head. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi, 6 pi over 4, 7 pi over 4, 8 pi over 4. Just count them out like that. Do you see what I'm doing? I'm not translating in my head, oh, this is 45, oh, this is 90, oh, this is 180. At the end, when you get 4 pi over 4, yeah, that's pi. Just reduce it. But start with your first one and count everybody in that. It's going to make your intercepts the easiest way to go. Otherwise, you got to stop, especially when it comes in between pi over 4. Okay. Do you have this one?
Yeah.
Okay. So we've got an amplitude change and we have a phase shift. This guy is starting at negative pi over 2. Did the frequency change? Nope, the frequency is still 1. So how long is it going to take me to complete one full cycle? 2 pi. And how long is each quadrant? 2 pi? 4 quadrants? How long is each quadrant? Where are my tick marks going? Every pi over 2, right? If I'm a full circle, 2 pi, every pi over 2. So every pi over 2, start with your negative pi over 2 and increment it by every 90. 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Keep this going. And it actually works better that way. So you're going to start here. This is your starting point. And then you're just going to follow your pattern. We amplified it by 3, so just multiply this by 3. 3, 0, negative 3, 0, 3. 3, 0, negative 3, 0, 3. Okay? So your cycles, if I asked you for 2 full cycles, I think this, did this say 2 full cycles? Or 1? 2 full. So 2 full cycles are going from 0 to 4 pi because my frequency is 1. Because your frequency is 1, you're going from 0 to 2 pi. If I want 2 full cycles, I'm going from 0 to 4 pi. I start like that. But because I have a phase shift, I got to start here and still go 4 pi and get to here. 4 pi is 8 pi over 2, right? So this way now, if I have 1 less, because I started 1 to the left, I'm going to finish at 7 pi over 2. Make sense? Okay. And again, your intercepts come off of where these guys go. You get a little nervous hearing the word intercept because everybody gets panicked with their intercepts, but you're already graphing from your intercepts. Every time you make a dot there for the 0, the 3, the negative 3, the 0, that's an intercept or a 0. That's a min, a max, and an intercept. So you're already plotting these points. Okay. Make sense? Okay. Did you have this one? I don't know why mine's different than yours. Let's see if I can move this down just a little bit more. Okay, you have a phase shift, you have a frequency change, you're now 1/2. So now you're going to do half the curve in 2 pi, so it's going to take you twice as long to make this. And you have a phase shift, you're starting at C over B. If you want to pull this out, make this easier, just make this 1/2 x, so you see your frequency change a little bit better. C over B, pi over 2, sorry, pi over 4 over 1/2. Key change, flip this, so it's going to be 2 pi over 4, or every pi over 2. So I start at pi over 2, instead of at the 0. But I have a frequency change, so I'm 1/2. I have an amplitude change also. You good with this? And as soon as you make that point, that's either your min, your max, or your 0. Those are the only points you're really graphing by. Remember, in precalch, we don't graph off of grids all the time, we just sketch. So make your sketch as simple as where your increments are going to be. Make it easy. You technically go in every pi, but because you have to start at pi over 2, and make your grid be in all pi over 2s. Okay. Did you have this one too? Okay. So we've got a reflection, we have an amplitude, we have a frequency, and we have a shift. Your phase shift, C over B, pi over 2 to the left. So you're starting there. Your frequency also says 2 curves in 2 pi, so your period's going to be pi. So it's going to cut down from where we have to go for 1 full cycle. And if you have to go 2, just go a little bit more. Just follow your same pattern. You tell me, questions, concerns? Can you guys do these? You have to be able to do these. And a tangent? Did I give you these? State the domains and the range?
This one, can we go back to this?
Yep. Did I miss this?
No.
Okay, I'm sorry. questions on this? No? When you see all this big mess, just break it down, take one step at a time. I find what's helpful is doing this, taking your original cycle, change your amplitude on this. If this has a reflection in it, this is where you can multiply by the -2. That's the points you're charting. So once you figure out where your tick marks are, you just mindlessly follow this pattern. As soon as you figure out your tick marks come from this. Here's your period, so you need to complete 1 in pi. Therefore, if you think about it, 180 divided by 4 every 45 degrees, or take your whatever your period is and divide it by 4. These are your increments. These are where your tick marks are going. Every 45 degrees. 45 is half a 90. So when you graph your thing out, if these are where your 90s are, all you gotta do is just think like this. Just put them in the middle. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. There's your intercepts. And at the end, just make sure you reduce them. Just make sure you reduce it. This is key, this increment. Okay? And then you just had to do the domain and the range. These are your tangent, cotangent, and reciprocals. Remember, your tangent and your secant have the same setup for the domain. This is the domain for the tangent and the secant. And this guy is the domain for the cosecant and the cotangent. Okay. You're going to start with your basic ones, and you're just going to adjust them. You're going to take whatever this x is in here, you can pull it out if you need to, or just leave it x over 2, that's fine. Take whatever this is and set this equal to this piece here, this x, and solve for the new x. This qualifier stays the same. Now, I also find it helpful if you sketch this, because remember, the problem is at your zeros. You can't take 0 over 1 and flip it. So every time you have a 0 in your original one, you have an asymptote in your inverse. So that'll kind of help you out. And tangent is just kind of straightforward. Tangent and cotangent. Remember, tangent and cotangent, their period is pi. And it's kind of nice because you can kind of see, there's your pi over 2, your negative pi over 2. Every pi, this happens. That's probably the trickier one because everybody else goes 2 pi. And your secants and your cosecants make off your original reciprocal curve. Make your sine curve, make your cosine curve, and do your reciprocals off of that. Do whatever frequency change happens to your sine curve and your cosine curve, and then draw in your other part. So I think all I asked you, not for the sketches, just to find me the domains and the ranges, right? Okay. There's a cosecant, and then we'll get to a secant. Any questions with this one? And then the last one is out there too. Okay. Keep the same qualifier that you originally had. There's only really 2 you have to remember.
Can you show how you would do a graph for the last one?
For this guy?
Yeah.
Yeah, when you do this, I haven't really asked you to graph these, because when you say x is equal to n, where n is any odd integer, you're going to set your graph up. You're going to set your graph up by 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, like this. You're going to set it up that way. And then you're going to say, these are where your asymptotes are, on your odd ones. So you're going to start like that. But I haven't asked you to do this because it's a little harder, and I mean, you can absolutely do this, but you have to keep converting, like in pi is 3.14. So pi over 2 is actually 3.14 divided by 2. Remember when you found them in your calculator when you couldn't get back to the thing? That's how they translate to your axis. It's a little tougher to do, but you can absolutely do it. But if you're going to do this, and I haven't asked you to do these, you can absolutely do them this way and follow it the same way. If this is where my pattern is and my asymptotes are here, then I know that I have to fill out 4 quadrants and go through this and over, figure this out, do it every 4 pieces, just separate these into 4s and do it that way. And then build your secant curve. But I haven't asked you to graph these, just to find the domains and the ranges. I don't really find the need to do those. I'd rather you be involved more with the angle than the decimal part of it. You know what I'm saying?
Do you know when any is all integers or any?
Because it comes off your original one. So as soon as I see the word secant, I write my original secant down. Secant and tangent do any odd integer. Secant and tangent have the same one. So as soon as you see your original, then once you do this, you set that equal, this stays, and then this comes right from here, whatever your original one is, whatever the original one was. And when we graph most of these, you can pretty much see where your zeros are. You can almost say it. The only one you're going to run into trouble with is the one where we had like every even. Remember when it came out on the 0, the 2 pi, the 4 pi? And we don't have a qualifier that says even, and that's where the 2n pi came from. It actually came out to be 2 times n, so that's what made it the even number. And like I said to you back then, if you took it off your graph and you gave me where n is every even integer, I probably wouldn't mark it wrong because it is technically not wrong, but if you're going off of one of these, it should be 2n pi. That's the only difference. The only difference.
Cosecant, could you scroll back up?
The cosecant and the cotangent, they both begin with C. That's an easy way to remember it. The cosecant and the cotangent, they both begin with C. They're the ones that have the same letters, they're the ones that are the same. The tangent and the secant, T and S, they come right next to each other in the alphabet. Whatever helps you remember it. It's those corny things that help me remember for my whole life. When you get those corny phrases in your head, and you never forget them, no matter how old you are. Someone says it, you say, oh, I remember doing that. Good? All right. So that's